So today it's perpendicular lines we're going to be talking about and the gradients associated with them. What is a perpendicular line? Well, if two lines are at right angles to each other, then they are said to be perpendicular. So if you imagine a square and it's got four corners, they're all right angles, so the adjacent sides are all perpendicular to each other. As far as the lines that we've been looking at are concerned, if you've got two gradients and you multiply them together, then if the answer comes out to be -1, then both lines are perpendicular to each other. Or if you are looking to find the gradient of a line that's perpendicular, what you need to find is the gradient which, when you multiply it with your original gradient, comes to -1. You'll always see it's always a wee bit easier when you see examples with numbers. So different types of notation. One way is an m times m, and it's got a wee subscript there. It's like an upside down T that represents a perpendicular or a right angle. Or m1 times m2, which equals -1. Okay, so m1 and m2 is your gradient, your two different lines. So let's look then at an example. So the rule for this then is if you know the gradient of one of the lines, then the gradient of the other is calculated by inverting the gradient, which means flipping the fraction and changing the sign. So an example of this, if you had one line where its gradient was 2/3, then a perpendicular line to that, a line that are running at a right angle to that, would be -3/2. You notice you've turned the fraction upside down, so the 3's in the top and the 2's in the bottom, and you've changed the sign, in this case from a positive to a negative. Similarly, if you had a line where the gradient was -5, then to flip that upside down, remember that 5 is just the same as 5/1. Even if it's negative, it's -5/1. So the 1 goes on the top, the 5 goes on the bottom, and the sign changes. In this case, it changes from a negative to a positive. Okay. Now, wee bit to remember, or remind yourself, this rule cannot be used if a line is parallel to the x or the y axis. We'll look at that in a wee bit more detail. So if a line is parallel to the x axis, and if it is, so that means it's horizontal, the gradient is 0, then if it's going along the same direction, parallel to the x axis, the perpendicular line is in fact the y axis. Goes straight up and down the vertical line. So just worth bearing in mind, sometimes it does crop up. So let's look at some examples. So this one here, given that the point T is 1, -2 and S is -4,5, find the gradient of a line perpendicular to ST. So a line perpendicular to ST. So you're given these 2 points. We can find the gradient between the 2 points. So if you look at labelling your points x1, y1, x2, y2, sticking them into your gradient formula, so you've got 5 minus -2, -4, -1 on the bottom. When you tidy that up, you get a gradient which is 7 over -5. So the top line, 5 minus -2 comes to 7, -4, take away 1 gives you -5. So that's the gradient ST. We want a line perpendicular to that. So we're going to have to do some of the things we just did in the last slide there. We know that ST is -7/5. We have to flip it upside down. So the 5 goes on the top and the 7 goes on the bottom. And we need to change the sign from a negative to a positive. So the perpendicular line is going to have a gradient of 5/7. Now we can double check it. It's one of the areas where we can double check, because if it's true, when we multiply these two gradients together, we should get -1. And of course, if you follow that process through, you find that -7/5 times 5 sevenths. All the cancelling out that goes on, you end up with an answer of -1. So you know you're correct. Another example then, if you think of a triangle, we've got three vertices, three corners, M, O and P. The coordinates of each is there to show that the triangle is right angled. So probably want to try and draw a diagram first. Make a wee rough sketch. Doesn't have to be perfect, but you know the rough position of M is -3, 9. You know that O, the origin, is 0, 0. P you're given as being 12, 4. Okay. So where would that right angle likely be? According to your sketch, it's likely going to be in this angle MOP. So we need to get the gradient of MO or OM, and we need to get the gradient of the other line OP. So let's look at this first, see if this creates a right angle. So the gradient of O to M, using the notation we always use when it comes to gradients, x1, y1, x2, y2. Putting that in, you get 0 minus 9 on the top, 0 minus -3 on the bottom. Tidy that up and you get -3. So let's look at this other line. So from O to P, so labelling our coordinates, 0, 0 and 12, 4. On the top we'll have 4 minus 0, 12 minus 0. So that simplifies to 4/12, which simplifies again to 1/3. So we've got two gradients. How can we show that these two lines that give us these gradients are perpendicular? Well, we could multiply them together. So if we took OM and OP, multiplied the gradients together, if it's right angled, if they're perpendicular, then it should come to be -1. And you can see from that calculation there that that is indeed true. So just to finish it off, putting a statement in there, since MOM times MOP equals -1, OM is perpendicular to OP, hence the triangle is right angled at O. Okay. So that there is really everything we're going to cover as far as the perpendicular lines is concerned. Okay.